doing a PhD jointly at the University of Trento and SAP. So a lot of the data that we have is actually motivated by real data from a big software vendor in Europe. Let's start with the first part. Why are we actually looking at that, and what is the problem of securing your software supply chain? Secure software development is a rather old topic. Everybody, when we're talking about secure software development, thinks about, yeah, there's the Microsoft secure software development lifecycle, or this is the one from SAP. That's rather standard. There's a lot of documentation out there. There are talks out there. Last year, I explained that one in more detail at the OWASP conference in Amsterdam. So what is actually the problem? Let's look how we developed software in the past and how we are doing it today. The left side from your perspective illustrates how we developed software. A few years ago, we opened our text editor. We started to write our small Hello World program in C. And the only thing that we have included there is the standard I/O. So not a lot of external dependencies. On the right-hand side, there's the same process going on for a Node.js-based application. And if you look closely at the screen, it downloads already 10, 20 different packages from the internet that we don't know. So earlier, software looked like that Lego wall. We have our red block, the code that we own, that we govern by our secure software development lifecycle, and a little bit of external code, mostly deeply buried beneath our coding from the operating system or system libraries like libc, the black one. Nowadays, yeah, we still have the operating system and the libc code, but there's a hell lot of other code, and more or less the code that we are developing is very specific clue code, very specific application-specific code, but most of the code actually is not under our control and is not governed by our secure software development lifecycle. Still, if we ship that product, if we ship that Lego wall to a customer, the customer expects that the whole wall, even so it's built out of several blocks, is stable and secure. And we are legally also responsible for that. So even so we don't have control over the development of all the small parts that build the system that we are selling, we are responsible for it. Why is this a problem? For some companies, that might be less of a problem. There are companies like Apple. Everybody wants to have an iPhone, and not an iPhone, the latest iPhone. People are queuing in front of the shops for getting the latest Apple gadget. That's actually a nice situation to be in if you're a software or IT vendor and need to fix security issues. I don't have the exact numbers, but let's assume, just for the sake of the talk, 90% of the customers of Apple, or also if you look, for example, at other software that does automated updates like the Acrobat Reader from Adobe, are on the last 2 versions that you shipped as a software company. That means roughly, yeah, not a lot of people are using the software that you released a few years ago. You don't need really to care about that. You only need to maintain 2 versions of your product, the latest one and maybe 1 or 2 more, but that's it. That's a rather small problem. If we are now going to the enterprise world, an area where SAP, for example, is active in, the situation looks more like that. Most of your customers are actually using software that you released 10 years ago. And then all those external components are really becoming a problem. Anybody knows how Node 0.2 works? Or anybody could imagine to support Node 0.98 in 10 years? Still in productive environments? Maybe Node programmers are becoming the highly sought resource like COBOL programmers, open source experts becoming the new COBOL programmers with respect to their hourly rate. Could be. That's actually not a very rare case. If you look at other companies operating or building systems for large enterprises operating in the enterprise space, maintenance life cycles of 10 years and more are rather standard in the industry. So Windows XP, where we are just happy that it finally is dead, and at least for the non-embedded version, there are no security updates for the general public anymore from Microsoft, and everybody should upgrade. It was released 2001, and Microsoft supported it with security updates until 2014. Windows 8 is already promised to be supported until 2023. And it's not only Microsoft, it's also, if you look at open source companies, the enterprise versions of Red Hat Linux are also supported for 11 years. And even pure open source products like Tomcat provide 10 years, or 9 years in that case, of maintenance. That means for the one major version that they released in 2007, they provide security fixes until 2016, and not only for the Apache Tomcat, for Tomcat as such, but also for all the open source dependencies or all the third-party dependencies they have in their coding. So third-party libraries are really big, they're everywhere, and they're a big problem or big maintenance headache if you need to support really your software for a long period of time. And that affects actually the software development lifecycle at all stages. Already in the training area, you need to start training your developers about things like what are the different types of third-party software that you have? What are software licenses? How are the software product maintained? What are the different maintenance models? Maybe even how does an open source community work? And what is actually a bill of material? If you go to the risk identification step, it just continues. You need also to assess the risk of using certain third-party libraries, and that risk is not a general one. There's not one risk associated with using Tomcat or jQuery. It heavily depends on how you use it in one particular product that consumes that third-party library. Therefore, you have to have product-specific plans about the security responsibility, the security processes, also the response processes. I come to that later on also. You also need to ship fixes when an open source product or a third-party component that you consume is being fixed and you are consuming that. You need to update that component or in another way ensure that your product consuming that open source component or third-party component is secure again. In the development, of course, you need to teach your developers and ensure that your developers are using third-party components securely. That means it's fine saying, I don't want to implement SSL as a protocol. It's a complicated protocol. I don't want to implement SSL certificate checks myself. It's complicated. Other people already did that. Still, those libraries have security-critical APIs, and you need to use them correctly. And we all know those many products that actually do not do proper SSL certificate validation because the API is not really intuitive to use. If you do security testing in development, the same. How do you test the consumption of your third-party software? Actually, would you test them in isolation to assess their risk? Do you assess the whole component? What do you do when you find vulnerabilities in a third-party component? How report that to a third-party vendor or to the open source community? All things that you need to consider. SAP has an additional validation step in their security development lifecycle where the final product is tested. Here, the same. You need to test the whole product, including all third-party components, and you need to be able to react on issues found in third-party components. And as already mentioned, the security response process needs to take care of the third-party components as well. So it's really going end-to-end through the software development lifecycle, and most likely I forgot a lot of other points where third-party components are affecting your security development lifecycle in addition. Let's have a quick look what type of third-party components are common in the software industry. The first one, there I put together commercial libraries, so that means if I as a software vendor buy a library from another software vendor, which then is my supplier, or if I make bespoke outsourcing, I go to a company and say, here I have a problem, please implement me in framework that I then use for building software for my customers. That would be something here, outsourcing. That would be if somebody is building a product on top of SAP HANA, for example, or an Oracle database. The middle one is freeware. That's all the software that is gratis, but it's not open source in the sense of the Open Source Foundation. So you don't get access to the source code, or more precise, you are not allowed to modify the source code if you would get access to it. So that's most likely in many cases a binary driver for a piece of hardware that you actually bought. So like the Jabra device drivers for the Jabra headphones, or the graphic card device driver from NVIDIA or so. These are binary blobs. You get them for free. They don't cost you anything, but you also don't have a proper maintenance contract for them. And then there is open source software or free software in terms of the Free Software Foundation or the open source initiative, where you have access to the source code and under certain conditions specified by the license are allowed to modify the source code. If we look at the upfront cost, so if I'm a developer and I'm now considering to be a developer in a big company, if I ask my boss about, I would like to use a commercial library, there I definitely have to trigger some official processes because I need money to pay the external party. It's not like in a small company where I can maybe just grab the credit card of my boss. So there's at least some hook in the processing part. Therefore, upfront costs are high, both in terms of processes within the company as well as monetary aspects. For freeware and open source software, upfront costs are close to zero because I just download them from the internet, easy to access. That's then also the ease of access for developers. If things are on the internet, I can just download them. Maybe I even recognize that I download them. If I start initializing Node.js application, it's actually completely hidden from me that the Node.js build system downloads dependency automatically, and the same is true for Maven in the Java world. It's just so convenient and everybody uses them. Am I allowed to change the software for commercial libraries? Might be, depends on the contract, but as I'm paying money, I definitely have a contract, so at least I should be very clear and should know what I'm allowed to do with that software. For freeware, usually it's impossible to modify. That's the definition of freeware. Otherwise, most likely it would be open source software or in the commercial library camp. Whereas for open source software, by definition, I can modify it, which means I could develop own bug fixes. So I have an additional possibility there in fixing security issues. And do I get a support contract? Yeah, for commercial software, that's the standard way. I'm negotiating a contract. Hopefully also the maintenance and support rules are specified there. For freeware, it's really, really hard. I mean, have you ever tried to get maintenance for your graphic cards device driver? I mean, those companies sell hardware. The software is kind of a necessary evil. They need to provide software to you that you are able to use the hardware that they actually want to sell to you. But it's a byproduct. For open source software, it's possible there are companies out there which offer commercial support for open source software, but it's not the standard and most likely not the first option people consider, because one motivation to use open source is I can just download it. And if I just download it, I usually don't have a support contract. Maybe I have support promises or support plans, like in the case of Apache, that for that version that I downloaded for the next N years, there will be security fixes, which is already pretty good. So as a matter of fact, open source software is widely used in the industry. It offers one possibility more than the freeware. I can fix stuff myself. I can myself take over the maintenance. And it has another advantage why we concentrated with our research study on open source software. There's actually vulnerability data available. For commercial software, it's pretty hard to get data. And when we are talking about data, we mean things like publicly available data, like OpenHub, which is a web platform where you can access data like the popularity of open source projects, the programming languages being used. It's kind of a standardized project format. It's not always the most correct data, but it's at least available. There's the Core Infrastructure Initiative, which is currently looking at a lot of open source projects, also looking at how they develop software securely, which gives insights into how mature the projects are with respect to their secure software development lifecycle. There are publicly available vulnerability databases like the NVD or ExploitDB, OSVDB that we can use for the analysis. There is project data available on the home pages of the projects, like the source code repositories, the revision in there. There are also companies that provide commercial security testing tools that offer them for free in a hosted scenario to the open source projects. And if you ask kindly, you get access to the test results that you can look at. And then within a big company like SAP, there are internal inventories. SAP is using a commercial software for that, where you can track which open source is actually used within the company. And before I hand over to Stanislav, let's have a quick look on the actual open source usage at SAP as it was last year, autumn 2015. For the 166 most used components, so SAP is using a lot of more, but that's only the top most used one. We see that most of the language program projects are implemented in Java, Then we have a lot of JavaScript and C as well. And if we look at the vulnerability side, we see that the distributed denial of service makes up the biggest part. And then we have code execution, overflow problems, bypassing security controls as the next one. And this describes a little bit the selection of the projects we look closer at. So keep that in mind when Stanislav is now telling you what our results are with respect to the analysis. It is, of course, biased towards this selection here.
Okay, hello. And I'm going to talk about the second part of the talk, which is the problems and the challenges that we had. We're trying to identify what are the risks in planning the efforts for secure consumption of free open source components. And nowadays we know that many free and open source components are shipped as a part of proprietary solutions that are sold by proprietary software vendors. However, the problem is that this software is often treated as a black box. And the reason why is that there are too many components, and acquiring the thorough expertise about each and every of them, it's too expensive. At the same time, if a component is shipped to a customer, the company that ships it is liable for security issues in that component. It doesn't matter whether it's open source or not. And at the same time, they have to provide the security maintenance for these components. So what the companies that do that want, they want to have this secure maintenance process as predictable and as deterministic as possible. At the same time, what they really wish to have is some sort of an oracle that will look into this black box, which is a free and open source component, and will answer various questions that will help the consumers. For example, they would like to know how many new vulnerabilities will be there next year in a certain component, so that the vendors would know what do you need to expect in terms of maintenance, and how many patches they need to ship to the customers in order to resolve these issues. So now I'd like to show you just an example, and the reason for this is that to answer the question, to build an oracle, we might use vulnerability prediction approaches, and there are around many of them, and there is a lot of research that is going into that direction. And in order to predict vulnerabilities, we need data, which is vulnerabilities. And this is the example of Tomcat 6, and here we plotted the cumulative distribution of vulnerabilities for the whole development period of that. And we can use this cumulative data in order to first understand what is our efforts, or what is the risk of application to being vulnerable to a certain number of vulnerabilities at a certain release that our customers is using. And at the same time, we can take this data, plug it into the time series prediction approach or regression models to understand what will be the maintenance actions that we need to do in the next year or next couple of months. So this is just one project, and the question here is whether we can try to get this data and to use it to plan the maintenance for 200 plus projects that the company is using. And the quick quick answer is not really, because the big issue here is that this data is not always available. Simple example, there are projects like Apache Tomcat, they have they use the same development technologies, they use the same programming languages, they're about the same size, they do the same thing, but they just don't have as many vulnerabilities as Apache Tomcat has. So the question is it a better project or is it a worse? And the only conclusion we can do here is that there is just no data, so we don't know. And we cannot really use vulnerability prediction here. So what we quickly did is that we took a sample of the projects and we tried to answer the question why so many good projects have so many vulnerabilities historically. And it turns out that it only depends on the age of the project. So the longer the project is on the market, the more stuff will be found, obviously. And it also depends on the number of users, because there are people who are willing to find bugs and to report them. And it seems that it also depends on the will of developers to disclose these vulnerabilities and to thoroughly document it. So regardless of that, as a proprietary consumer, you still need to do something about the component that you are using, even if the data is not available. And sometimes you just have no choice, because nobody will re-implement a known Hadoop from scratch, for example. So we did a small study here to just trying to identify whether we can find some characteristics of free and open source component that would explain what would be the problems of the maintenance in the future. And as I already said, it's not really possible to predict when a new vulnerability arrives when you have no data on the past. So the question is here, can we take the sample of the projects that the company is using, and can we distinguish some specific characteristic of these projects that will help to estimate the problems in the security maintenance for these proprietary consumers. And here we use the direct maintenance effort as the notion of problems that we want to predict or estimate. And here we try to answer different questions. So is it true that there are only vulnerabilities because people tend to report them? Or does, for example, the technology in which the product is being developed matters? So is, for instance, Java better than JavaScript in terms of problems? If the project is developed in Lisp, then nobody would care to hack it, for example. So what we try to do here is that we used all of the data sources that Akim showed you earlier, and we tried to collect as many data as we could find there. So we tried also to build a regression model, not to do any kind of a prediction, but try to identify an impact of each and every characteristic of a project to the maintenance effort. And the first thing is we collected everything, plugged it into the regression model, wanted to see whether we can see something. So for example, we tried to capture the evolution in the source code of a certain project by looking at how many lines of code were added during the development in a certain periods, how many of them were removed, and also, for example, we looked at the size of the project in terms of lines of code. And then we tried to build a model. So as it turns out, that was a mistake, because first, in order to use any kind of prediction models, statistical mechanisms, you really need to know what you're doing. So you need to build certain hypotheses around the data, and you need to know what are the assumptions that you make around the data, and first you have to verify these assumptions. Because here, we treated every parameter as every characteristic as a variable, and in regression model, you assume that all of these parameters are independent. And only after that you can get some reliable results. However, when we plotted the added and deleted lines and also the size, we've seen that these variables are perfectly collinear. So basically, if we use all the data that we have, we don't get the right results. So first we need to study if there are some internal dependencies between the data before we get the results. And also what we learned after we were speaking with developers, which is quite obvious actually, is that all of these factors that characterize the project, they also might influence different maintenance strategies that could be applied to them. So to give you a short example, one extreme is that you have 60 products, and for these 60 products, you ship Apache Tomcat as the core component. And as some of you might know, Apache Tomcat is a very complicated product, and if you need to analyze it for vulnerabilities, even if you use complicated static analysis tools, it really requires a lot of expertise to really filter false positives and find false negatives. So in that case, it makes more sense to have some sort of a central security team within a company that will know Tomcat by heart, and that will help other developers and other teams to resolve security issues in older versions or to find the new ones. And there is another extreme example, which is just two development teams are using a small JavaScript library which doesn't require any expertise, and they can easily fix it themselves. So obviously, you don't need a centralized team that will spend their time on just fixing this small library for these two guys. So now, just the models that we try to do for these two extreme cases. So we called it the centralized model. And here, it might be the case that in company there is a policy that in order to use an open source component or any third-party component, it has to be approved within the company, it has to be certified, and you cannot just select the arbitrary one. So in that case, as I already said, it makes sense to create a centralized team that will own all the expertise about these components, do the fixes, provide consultancy, and distribute the patches to the customers and to the rest of the teams. And here, there is an initial setup cost in this team. So for instance, first you need to establish team, and you need to train it, and then you need to establish communications between the team and the customers and the other people within the company. So there will be some initial cost to that. However, the effort here, and we model this as the number of vulnerabilities in the current version that is being used and the number of products that it is using. In that case, since there is one team that is doing that, we'll scale logarithmically with the number of products that are using the open source component. The other case could be described by a distributed model in which there is a full freedom of selecting any kind of software that you want to reuse with your products, and each development team has to take care of them. On the downside, on the upside, you don't have the initial cost of setting up teams, providing trainings, and etc., because everybody is on their own. But if we go back to that JavaScript library that has only 2 users, if we have tens, thousands of users in 1 year, and everybody is fixing the same things, the company will spend a lot of stuff, a lot of resources in vain, because apparently the centralized team would do that. And actually, none of these models is used as is in companies, and of course, every company has something unique, but to generalize that, there is some sort of a hybrid model in each company. For instance, when the component is used only by a few products, there is the distributed model. So people have freedom to maintain it, to do whatever they like. And after a certain threshold of number of usages is reached, which is V0 on that graph, then centralized models kicks in. So there is a security team that knows projects like Apache Tomcat that helps people to resolve the issue. So in the end, you try to minimize first the initial cost. You don't give each and every product to the security team, to the central security team to spend their time on, and at the same time, you try to cut off the cost with this linear growth when everybody is doing their own things. And to really assess these models, we really need to get more data that we have from these sources. So we need to talk to developers of open source components. We also need to get into the software repositories and study in deep, basically all the relationships about these factors. But this preliminary analysis that we did, first it shows us the importance of the problem, and it allows us to come up with recommendations with respect to the selecting open source component that you might want to use in your company. and security maintenance of that component if it's been already selected and you have multiple versions of it running with your system. And I give the stage back to Akim. Thank you.
So, okay, that sounded now rather depressive. We need more data. We don't really know where the best switching point between a centralized model and a distributed model is, where to switch to the hybrid model for a given component. So, very depressive. On the other hand, a lot of interesting research ahead of us. So interesting times. But still, from a pragmatical perspective, if you're working in industry and want to do your third-party consumption more securely and be aware of the resources that you need for that, there are some pragmatic recommendations that we have based on our experience. So first, if you look at the secure software development lifecycle, maintain a detailed software inventory. Be aware which third-party components you are using, in which version, and in which product. And do not forget the dependencies of those components. Which is pretty challenging, because if you're using something like Cloud Foundry, one component might have several hundreds, if not thousands, of dependencies. But still, if something like Heartbleed happens, it's a big advantage if you immediately can look up in a database, oh, only those two products are actually using the vulnerable SSL version, or the other ones are using different SSL libraries or different versions of OpenSSL. That helps a lot to go back to business as usual and mitigate the risks and really work on the actual problems. You need to actively monitor vulnerability databases for open source products. There's one difference of an open source product compared to a third-party component, commercial third-party component. In the proprietary software consumption case, the vendor of the proprietary component usually notifies you if there's a new version fixing a security problem in the software. An open source product doesn't actively notify you about there is an issue in this library version, it has security impacts. They might publish a CVE, therefore you need to monitor the CVE databases, or if the projects have dedicated websites or mailing lists, you need to monitor them. And assess the project-specific risk of third-party components. They might be different. There might be issues where even security issues in a third-party component are not exploitable because they are deeply inside your application and there's a lot of protecting code around them, versus we are talking about a JavaScript front-end library having a cross-site scripting issue, which most likely is then also present in your product. Obtaining components, interesting part. You can download them from everywhere on the internet. Please download them from a trustworthy source and use HTTPS for downloading them, that you really know I'm getting the original version of Tomcat as released from Apache, or if you prefer to obtain it from a Linux distribution, Debian, Red Hat, SUSE, whatever, use their repositories, but really use a secure and authentic channel for obtaining your software. The next part for controlling risks, if you have the chance for selecting projects, and that's actually in reality a rare situation. Often you don't have a chance. There is no good competing product to Hadoop. Customers require Hadoop compatibility, the Hadoop API. So if your customers are asking for Hadoop, you need to use Hadoop. If your customer is asking for SSL support, there might be multiple SSL libraries out there and you can choose from. If you have the situation where you can choose your open source product or your third-party component, then look at issues like, does the product provide a private bug tracker for security issues, or a dedicated bug tracker, mailing list, whatever, for security issues? That's important that you are not, that it's not a surprise or people starting to discuss security issues before a fix and a CVE is available that you can then use for fixing your product. It minimizes the time in which your product is at risk. And look at evidences for a healthy, working, secure software development lifecycle at those components that you are consuming. Things like, do they document security fixes and patches properly? Do they avoid doing secret security fixes, so fixing functional and security issues together and not properly announcing that it's a security issue being fixed? Because then an attacker might just mine their source code repository and find those security fixes and build exploits based on them. Or are they using security testing tools? And there's actually one project that started last year. It's the batch initiative from the Core Infrastructure Initiative, or the batch program from the Core Infrastructure Initiative, which exactly looks at these kind of SDLC-related properties of open source projects. And the goal is to then assign silver, bronze, and gold colored badges to those projects, depending which maturity level they have. So that should help you in selecting them. Looking at the effort, strategies for controlling your effort, because if you're a software development manager, the things that you want to control actually is the risk of the product that you're developing and the effort that is required for developing it. So again, from the secure software development lifecycle perspective, it is in general recommended to update early and often your open source components. Also, maybe think quickly before the release. If you're doing a rather traditional software development, then between selecting a component and shipping your product to a customer, there might be half a year or more in between. There might be a new release shortly before you want to release your product. Maybe you can update and integrate already new security fixes. Avoid own forks. They are costly. Work together with the open source community in fixing bugs. We believe that this on the long term is a win in terms of effort compared to quickly fixing something and not really working together with the community. Again, project selections, Stanislav already motivated that. Look at healthy projects that have a large user base, an active developer community. The rationale behind that is there are a lot of users, a lot of developers. The project will not die tomorrow or next week. And if there's a problem, you might get more easy help from other people. Prefer projects that use technologies that you are familiar with. Maybe if you're a .NET shop, it's not a good idea to integrate a Haskell or Scala component when nobody in your company knows how Scala and Haskell actually work, because if you need to fix something, then you need to build, recompile, and change those open source projects. And if there is a highly severe security vulnerability, then under a high adrenaline level, which is definitely something you want to avoid. Look at the maintenance strategies of the projects. Something like Tomcat works nicely in enterprise environment. It has roughly the same maintenance strategy of roughly a decade. Using something like Firefox or Chrome, which just push releases every other week, might be a little bit more difficult if you're in an enterprise model for on-premise software. Might work nicely on a cloud model where you're yourself are doing updates every other day. And maybe also look at the size, less complex, smaller projects if you only need parts of the functionality. I've seen situations where developers integrated millions of code and actually they only needed 200 lines of code. So maybe think about that as well. More code means more chances for vulnerabilities, more things to maintain. And finally, the conclusion. Do not waste unimportant time with unimportant questions. Personally, I think the question if open source is more or less secure than proprietary software, it's a waste of time. Everybody is using open source. There are bad open source projects as there are bad proprietary software. There's very well maintained, very robust open source software as there's very robust and very stable proprietary software. So it's a development model, but not a quality assurance model. And implement a secure software consumption strategy. Think about what you do, risk assessment, plan the efforts, and also think about the responses and maintenance. And finally, the final advice I would like to give is accept that there can always be a black swan, a very unlikely but very severe event. Regardless how mature your development life cycle is, how mature your third-party consumption strategy is, something like Heartbleed can hit everybody of us. But if you are well prepared, then you can manage that situation. If you have a good software inventory, for example, you know exactly Heartbleed is only vulnerable. The OpenOS, what was it? OpenSSL 098EF. You can immediately look up. There are only 2 products that I developed that are using those libraries. I can concentrate on those 2 libraries compared to the situation, oh, there's a big OpenSSL issue. Which of our products are actually using OpenSSL? And you first need to investigate that. These are things you want to avoid. And if you have time after working with your customers and fixing the issues, then you can still look if there would have been a possibility to detect that black swan earlier in your software development life cycle. But it shouldn't be your first priority if that event actually hits you. Thank you very much. We are now happy to answer questions.
My question is about maintaining local inventory of third parties and so on. So it looks like a very easy task when you have only maybe 1 or 2 products, your own products. But if you talk about a situation when you have, for example, 50 products and so on, and you need to maintain such inventory. So how can you do it?
So I was asked to repeat the question. The question was about the software inventory. It is a big problem if you have multiple projects, so 50, 100, thousands of projects with a lot of dependencies, how you can actually build up such an inventory and how to maintain it. That's really a big challenge. There are software solutions out there which try to analyze the build process and grab information, extract information automatically out of them. That's definitely a first step. And also forward-looking, I would suggest to start with recording the dependencies in the open source that you're using in the new products or whenever you're importing a new component, and not first trying to work up the backlog that you already have the old stuff. But yes, that's also a problem where pragmatically better solutions are required.
Maybe we can ask developers to provide this information in a regular way, and can we do it?
So question is, can we just ask the developers? In our experience, that doesn't work well. Not because the developers don't want to collaborate, but it's extra work for them. They might not be aware what components they're actually importing because it's hidden dependencies. And also, they think about one version they import and forget then that they are updating those components regularly. So I'm strongly in favor of having that solution automated as much as possible and would concentrate my focus on that instead of asking developers to do it. Again, I'm not blaming the developers. I wouldn't be able to keep manual record of that neither. I couldn't do that myself. So
the solution or something like that is to scan automatically code repositories and grab all dependencies and try to map it to public information about vulnerabilities, releases, and so on.
yeah, you in principle have 3 ways where you can scan software, either on the source code level and trying to understand all the imports on the language. In some situations, you can analyze the build systems like Maven build files, or you have an own Maven repository that you can analyze. And thirdly, there are tools that try to analyze binaries or whole installations or whole virtual images and scan them for signatures of products. They all have false positives. They are not perfect, but that's another problem.
I know OWASP has project like dependency share or something like that. Maybe it can be also some kind of solution.
Yes, there are besides commercial offerings also OWASP has at least one. I don't remember the name, but there are also 2 or 3 others that try to do that. It's definitely something to look into it. If you're in a company again, question again is, does it support the most important programming languages, build environments whatsoever? So I think in practice there are still a lot of problems to be solved.
I'm thinking about there's a big deliver out to client devices, whether they be desktop computers, mobile phones, and software that you deploy on a server. Because if you detect a bug in an open source library or component, and you only deploy on a server, you can fix it yourself and no one will know this, and then you can in due time tell the developers of this and they can have their handling of it. But if you deploy your software on client machines, you must decide either we fix this ourselves, ship our fix so our product is secure, and now everyone can binary dip this and we ODate any other users of this library, or we tell the developer of the library and ODate ourselves.
Yes, so the question is, there's a difference between, I simplified a little bit, cloud solutions and traditional software shipment in terms of when do you notify the third-party component that you are consuming that they have a vulnerability if you detected it. That's completely true. That's also one of the motivations why I said there should be a secret way, a non-public way of reporting security issues to projects, to avoid that if I'm publishing a fix for my software in the shipment model, that somebody can analyze that and I create unwillingly a zero-day vulnerability for all the other users of that component, or the other way around, that I'm zero-dayed by the project doing that too early. And the big open source projects have these kind of means of reporting it, and they also have working together with their customers. And sometimes you see for big ones like Zen, reserved CVE numbers, and there are certain time windows where companies like Amazon already restart their virtual machines. So they're all on a new Xen version before the vulnerability gets public. But that's another important point to look at and think about. Thanks a lot. Yeah, so the comment was about the licensing problems and the different effects different open source licensing models have on your own code, like the GPL being a reciprocal license. Yes, that is a big issue. I mentioned it only once or twice because I wanted to concentrate on the security part. But in my experience, actually in company, it's often the lawyers, the legal department, that starts the open source initiative first, looking at the licenses. And then the security people start looking at it as well. Technically speaking, it's a very related problem from the component detection and dependency issue. Luckily, open source projects don't tend to change their license so often. So you don't have regularly to monitor the license updates, but very valid point.